Today we'll be briefly talking about the GIT. So, I just want to make this video kind of more of a hands-on instead of talking a lot. I'll try to do more and try to demonstrate how to use this tool as such. So that kind of this is proper use of your time and kind of not taking a lot of time just talking about the stuff which makes no sense. So I'll just try to make it to the point and try to keep this video as shorter as possible. The intention here is not to make a very long video, but rather make something that's useful and that can be used as a reference whenever you need. So even though I don't want to talk much about theory, but still I would just like to give a brief background what this tool about and what it does, so anybody who is not familiar with this tool kind of gets the feel of what we are going to demonstrate today. So GIT, it's a basically a version control system that is used to kind of control the source code, or it is also called as source control systems. And this is not something new. Kind of this started in 1972 when this was taught in colleges and universities, and then this tool evolved into different flavors and different versions. And what we have today is a very modern version. It's a GIT, and it's a very handy tool, not very complicated to use. And this tool basically differs in the architecture of what we have seen in the past and even until recent kind of 10 or 15 years back. So I'm pretty sure whoever has worked on any IT project, they are familiar with some kind of source control tool. One fine example is your SVN. So SVN was is still widely used source control system or the tool in many organizations. But personally, I feel GIT is much more modern, much more versatile than SVN, and this is what we'll be seeing today. So I'll also show you how to install the tool, how to use it, and then also a few very commonly used commands that you might find it useful whenever you're working with this tool. And moreover, I'll provide you more details as and when kind of I reach to that particular point in terms of the tool architecture and other stuff. So let's get quickly started. I would like to start with installing the tool as such. And to install that, all you have to do is you have to go to git-scm.com, and then here you will find all the versions. So since I'll be using Windows machine today, I'll probably using the Windows, and the site is pretty smart. If you're trying to access this through a Mac, it identifies and then it will give you the link for Mac. Nonetheless, you have all the options where you can install it for Windows, you can install it in Mac, and this is also you can also do it in Linux. So for that, you can just go here, and then you see different options. It says Mac OS, it says Windows, it says Linux. Mac OS and Windows are pretty straightforward. For Linux, you have to go and follow the instructions that you have based on the flavor of Linux or Unix that you're using. They're not complicated at all, really easy, very simple to install and follow. But since I'll be using Windows, probably will just go ahead and use the Windows version. So you download it. You can download it by clicking here, and then since I already have a version of it, it's trying to kind of save me another copy, but that's okay. I can just I can save that, and then I can use that for installation purposes. So let's go Now once since the software is downloaded, what I will go is I'll try to install it, and I'll try to use the version that I kind of downloaded earlier. So one note, yeah, just say yes to this one. Probably this is the feature of Windows where it asks you whenever you try to install something new. Most of the stuff I'll be using will be something that's default, that comes default with this package, but you're not bound to only use what I'm doing. You can always go ahead and change. One thing that I would like to make, I'll keep this as a default. Yeah, this is the thing I wanted to mention. So basically it asks me which editor I wanted to use. So I'll be using Visual, but also if you are using Mac, you can use Nano, Atom, or if you have anything else, you can just use whatever editor you have. But since I'll be using Visual Studio, so I'll be using as a default. Then you can do next. Most of these stuffs are self-explanatory. Here again it says if you want to use the Git bash, or you want to use some external. I mean, I'll go with second since it's recommended, but again it's optional. You can select whatever you prefer or whatever your choice is. Again, same, if you want to use SSH from Git, or you want to use external, I'll go with default. Similarly, for SSH library, I'll go with the default. Here basically this says whether you want to type your script in Windows language and then convert it into Linux style. I'll go with the default since this is a Windows machine, but you have the other options as well. You can just read it. It's pretty self-explanatory. Do that, and then here it says use MinTTY or Windows default. So basically, if you are using Windows 10, go with this one. If not, then probably you can try using this one. But since I have got Windows 10, I'll be using this one. I click on next, and then again next. Probably I just don't want to take too much time reading all those options that you have. So I'm just going with the default settings. Similarly, whatever is default, just go that. Use next one. You can select this. I'm not selecting any of them, and then based on this, then it says install. But since I already have this installed, probably I'll not be doing the install, but you get the feeling. All you have to do is just click on the install button, and then the Windows package will get installed. Alright, so this will take a minute or two to get installed, but once that is installed, you can go to your bash shell, or let me close this and open again. Since this is a window, I'll use Git, and so basically I'm using their shell, and this is my Visual Studio editor that I'll be using today. Let me close this one so I can open it fresh and then show it to you what here it is. Alright, and for demonstration purposes and just to show you what I'll be doing today, let me close everything and then just open everything new. Alright, so this is the terminal for Git bash, and just to check, just to make sure we have the correct version installed, all I have to do is just enter git double dash version, and this will tell you the version of Git that you have installed. So since we installed Git 2.33.0, this is what is showing here for Windows, and this might be different based on the version that you are installing. Right, so once you have this installed, and then probably you can also type which Git, and this will basically give you the path where your folders are installed, or where the Git software is installed. So once you have got this software installed, probably there are certain configurations that you would that you should make before you can before Git starts tracking your changes. So basically, this configuration can be done at kind of three types of. I mean, you have three types of configuration that you can perform. One is your system level configuration, then you have also user level, and then project level. So it's self-explanatory. I would like to show you some of the user level configuration that we should make. Kind of a standard practice, just to make sure, kind of Git knows whenever you are trying to commit the changes. Uh, so if you just do git config, so this basically will give you all the kind of things that you have. And if you do git config dash dash list, this should show you the configuration that you have. So basically, if you look here, I have all this configuration, and most of them are default. I did nothing. The only two configuration that I made and will also show you is the user level configuration, and they are here. So how you did that, how you can do that is you just go, you do git config, then 2 dash global, then you do user dot name, and then you can type your name. Let's say if I do right, oh, I'm sorry, I mistyped it, so I'll come out of it. I'm sorry, I kind of instead of closing the double quotes, I did not close it. So let me then get config dash dash followed by global, and then you have got user dot name. It's in double quotes. I say I close the bracket. Right. So I have set my name. Now I will also, I'd like to reset my email, so I can set up that here. Config again 2 dash followed by global, and the other one would be user dot email, and that will be, let's say, no one at test or anything. This is just test.com. Alright, now so if I do get config list again, so probably you see, these two parameters which I had something, they got updated. So this is how you set up your configuration, and basically this configuration is also located in your folder where your Git is installed. So if I just do ls minus litr, so you see this file. So this is the file where this information is stored. So if I just open it and show it to you, sorry. Dot get config. So probably you can see the user level settings that I did here. So basically I set name and email address, and you can see that one here. Alright, so that's the kind of brief setup that you have to do. Now there's one more feature that most of the people kind of like to have, and which is not needed in Windows, because Windows has got that already in it. It's called auto completion. So auto completion basically means that, let's say if you're typing a partial name, it will fill up your rest of the information, or at least to give you the suggestion of what all names you have matching that pattern. So I'll show you how to, in case if you're using Mac or Linux, I'll show you how to do that. Probably you can just go to um, github.com/git. You can go here, and here in Git, if you go to contrib branch, here you have got completion. So basically, based on the kind of bash you are using, you basically open this one and then save this bin file in your profiles directory, and then you just have to add this text to your dot profile or .rc file. So whenever you try to log in, this will get invoked. So basically, since I'm so it's really easy. You can give it a try, and since I'm using Windows, I don't have to do that. Alright, so let's go back to our Git, and I'll try to now show you some of the important commands that might be really helpful while working with Git. And the first one is git help, and this is kind of the most commonly used command whenever you face an issue, and this comes with almost every OS that you have. So in case if you're familiar with Linux or Unix, they have got man or manual command. Basically, you can type that, and that should give you help, or the kind of the different parameters that you can use with that particular command. Alright, so enough of talking. Now let's try to show you how Git actually works in real life. So for this demo purpose, I have created, and I'll close this since I don't need any of this. I've created a folder called Git on my, and I'll just try to delete this. So that we can start fresh. The intention is here just to kind of show you, how easy Git is and how you can use for your day-to-day work purpose. Alright, now so if you look, this folder is the part of this folder is users desktop and Git. I will try to navigate there. So if I go to cd, okay, let me copy that. Alright, so did something wrong. Sounds desktop. Sorry, looks like mouse is not working properly today. Desktop, and from here I can just do Git, and there. So if I do ls or list everything, let me get rid of this one. And I'll tell you why I did that in a second. So if you look, I'm doing this folder is currently empty. I don't have anything, no hidden file. I usually usually lists any hidden files that you might have. So the reason why I removed that folder is to show you that there's no tracking happening here. So basically, for Git to start tracking your changes, it has to be initialized first, and now since I removed that folder, Git doesn't know what to do. It cannot track anything. So if I do anything, it's kind of, this folder is untracked as of now. So now this is my Git folder. So the one that was kind of just showing you. Let me create a folder. Let's say give me a text file. Let's say hello world dot txt. Right, and let me add hello world and save it. So one thing you can say, since there's no get, my editor says nothing. It just kind of opens this as a text file, and if I go to my path and if I do a list, probably you see there is a whole hello world text file and nothing. Now since we have got this file, now let's first initialize the get, so that get knows what to track, and it starts tracking the changes that we are making to this folder. So to initialize, it's really simple. All you have to do is git init, and if you see, it says initialize empty git repository. So basically the folder that I deleted initially, and now if I do a list again, that will appear here. So if you can see, it's a directory, hidden directory. So this basically tells get that it has to track the changes in this folder. Now if I go back here, you see the color has changed, which means my editor has started recognizing that this file, the one that I created, is still not tracked because we haven't done anything. All we have done is just to initialize the get. And how can we find that? So it's really simple. All you do is just look, get status, look for a status, and if you look, it basically tells you that there is a file that's untracked. And it also says there is nothing to commit, because we haven't made any commit, obviously. So it's pretty generic and nothing has been added. Alright, so this is how you initialize the get, and let me show you, just to kind of rule out any curiosities that you might have. Let me go to git folder, the hidden folder that got created, and see what's there. So here basically if I do listing again, so basically you see some of these are the files that get created. Basically head is one of them that I'll be talking about briefly. Basically this helps get in tracking your different versions, and kind of knowing what has changed and what to where to point at. So I'll come out of this folder, since there's nothing we have to do that. We don't want to change anything. Now let me demonstrate how get works, and then basically once I show you that, I will just come on and then display. I'll briefly talk you about the architecture of the get. So now since we already have a file here, and Git identifies that there is a file which is still not tracked. So adding a file to the repository is really easy. All you have to do is do git add, and if I do a dot, basically if you're familiar with Linux programming, this basically says your current directory. Add anything add everything that you have to this the staging folder of git. But alternatively, in case if you only want to selectively just go for one file, or just you can do hello, and if I do just tab out, if you remember I was talking about auto completion thing earlier. So if I just enter hello and do a tab out, I see that it will populate the complete name, and if I just hit enter, you see it says it has added my file to the staging area. Now if I do get status again, so now you can see initially it was saying the file was untracked, and now it says changes to be committed. So basically it says it has detected a new file called hello world.txt. It has added to its staging index, and so this is still not committed. And kind of that's my next point that I wanted to discuss, how get works. So if I have to commit this, so all I do is get commit, and then You can pass a -a. Again, it means that you want to commit everything, which I can do in this case since I have got only one file. But that's not the case in most of the cases, right? We only wanted to commit one file or the changes that we have made. So for that, I will not use -a parameter, but we will use a -m flag. That means, and M stands for kind of message, commit message that we want, and this is a required thing, otherwise it will not work. And this can also be used as a brief documentation. So let's say this will be, I'd say, my initial commit. So this basically, and I'll show you how this comes handy. Here you can just provide a small documentation or the brief write-up of what you have done. And again, this message can be a single line, it can also be a multiple line. So basically we just try to write a brief documentation on what we have done. So if I just enter, so now here if you look this, it says that one file change, one inserted, and then it gave me some hash value. I'll talk about this one too in a second. And now if I go again and then just do git status, so it says nothing is there because the changes that we made, it's already committed to the repository. And now if I come here, you see the color has changed, and it used to be green. Now it's kind of a regular color. So now coming back to the okay, let me show you one more thing before I talk about the Git architecture. So I was talking about this message, right? So if I have to see what I did, how that message comes handy, so all I have to do is just do git log. So if you see here, this is where you see, so basically all the setups or the configuration that we have done comes into play here, and probably now this will make much more sense to you. Like okay, so this is the one that I still have to talk about. It's a SHA1 value, and head and master kind of try to, when we saw all the files that get placed, head was one of the files. So I also have to talk about this, and we'll do that now. Again, see, you remember author, so this is the name and email address that we configured when we initially set up the Git. So this actually helps out. So since this is an open source, and let's say if you are working on something community project basically, and somebody has any, and the people want to reach out and kind of, you understand, right? So this information becomes handy, and this tells you like time when the commit was done, and this is the message that we entered while committing the code. And this one keep on, the Git will keep on tracking these changes and messages as and when we do more commits. So one thing now let's see how Git does this, and what is the architecture with the Git compared to the other source control tools we had. So basically, let me see if I can show this to you in MS Paint. So basically, all traditional source control that we had, so basically they used to work in, they used to have two layers. So one thing they used to call the first layer, they call it as a central repository, and then they also had a second layer that they used to call it as a working directory. So basically, if you take an example of SVN, so SVN has got this architecture. It has got a central repository, and everybody working on that file, they download and they make a working copy of it in a working directory by doing a checkout. So whenever you do a checkout, basically you are getting the most up-to-date file from the repository, and then once you are done with your changes, you just go and do a commit, and then that goes and updates your central repository in SVN, and that works perfectly fine. I don't. The only issue is that particular central repository that you are storing all your files, that becomes your single point of failure. So in case something has to happen, let's say for instance your central repository goes down or something happens, and everybody is stuck, nobody can get the code or can make the changes, or nobody can commit their changes. So that becomes a single point of failure. That's the beauty with the Git. So Git is kind of more of it has got more of what you say. It's it has got a more of a decentralized architecture. Sorry, I was just trying to find a proper word to say that. So instead of having one central repository, Git have many or multiple copies. So like each machine, each user will have their own repository. They are no longer dependent on the central repository. In theory, it does also have, you can say it, but it's just more of a naming convention that we follow. But it's more of your user level tracking that happens. So there's no single point of failure for Git. So the main difference when it comes to architecture is Git adds one more layer here. So let's say Git add a third layer, and so this becomes your because your repository, then it says it has got a staging area, and then it has got your working directory. So what we are seeing here, so if you go back, so this is by default you are in a working directory, so that's how it says your changes were not tracked, because it was looking at your working directory. When I did add, when we added to the Git, it moved that object to your staging index. It's still not there in your repository, but it added to the middle layer or the second layer, that's called staging layer. And then when I do commit, it goes and sits in your repository. So that's how after doing the commit, it says everything is done, you have nothing more left. So that's the architecture of this. Now we also spoke about this value. So basically, how does Git ensures that your integrity of data is maintained, right? I mean, because when we do multiple commits, Git has to make sure that nothing is lost or data integrity is maintained. So that is done using SHA algorithm, SHA1. It's called SHA1. Basically, it's a hexadecimal number, 16 digit, and then whenever you make a change, Git runs it through the SHA algorithm. It derives a checksum and gives its number basically. So if this is my first thing, first commit, so this is a number, and this number will keep changing. So if I'm doing, let's say, another commit, let me do this. So let's go to our folder, and let me add one more line. Let me say this is my second line, and I save it. So if you see, my text editor has identified that it's not tagged. I can go and do a git status. It will identify the file has been modified. So let's quickly go add this so that we can, so I can show you what I'm talking about. I do git add hello, and let me do git commit -m. This is second commit. Alright, so you can see it says basically one file change, 2 insertions, 1 deletion, right? Now if I do git log, so now you can see here basically if you look at the just number going, you see this 7078E, this was my first commit, and then when I did the second commit, you can, which is kind of evident from the message here, it has given me a second number. So the way Git tries to maintain the data integrity is it tries to take whatever was done in first commit plus any changes that was done after that, and it then tries to run it through the SHA1 algorithm, and then it comes with a a new hash value or the new this hexadecimal number, that actually tells Git to helps Git in maintaining the data integrity. So let's say if somebody tries to change anything or play with the file, Git will know, because then the checksum will not match, and that's how Git tries to make and Git ensure that your data integrity is never lost. Now, other thing that kind of I mentioned we haven't spoken about is the head. So you see this one, right? When we kind of went to your .git folder initially, there was something called head here. So head is nothing but basically it's a pointer that points to the tip of your current branch or in the repository, or your last state of repository where you made the commit. So if basically what I mean, to put this in a real life, head is a pointer. Let's say if you got a hard disk, of any size, and you're trying to write a new content to it. So there's a pointer that says which track is next available, because obviously you can always go back and refer any of the tracks or your memory blocks that you have. But when it comes to writing, the hard disk knows exactly where the next free block is. So its head is kind of similar thing. It always points to your last save area. So kind of it always know what was your last commit, and it keeps on moving. So to show you this, if I scroll a little bit up, when we did the first commit here, so I'll just highlight it. When I did the first commit, my initial commit, you see head was pointing at the master, and master is your so it was kind of head and master was the same thing, since it was the kind of your source code, and your pointer was pointing at the same place. Now after our second commit, if you see, say the head has moved to the second one, because it has to know what was the last commit, and that's how it keeps on tracking. So if I do another commit, let's say if I make another change, say this is third line, and save it, so my head will move, Git will know. And let's say if I do git status, sorry, I'm in wrong directory. So if I do git status, now it has identified that there is a change made to my file. And let's see if I do git add hello, and I do git commit -m third commit. So, and now if I do git log, so you see my head has moved to the third commit. So that's how it keeps track of all your commit. So that's the uses of Git. Now I'll quickly just show some more command. Basically, I mean, this was all kind of related to the tool, but for your day-to-day use, you have already seen how to add a file, how to track your, how to modify it, and how does Git knows is how do you commit it. So let me add one more file here. So if I just go and say second file .txt, this is second file, and I save it. And if I go to my terminal, I do git status, you'll see that Git will recognize that immediately, second file. So now I can add it by using git add, I can commit it using git commit. One thing I missed to show you when I was talking about the hash values, these values. So basically, if I have to go and see what was there, so all I can just do git show. Basically, this one will tell you what changes you did with that commit. So in case if you have to go and see your prior commit changes, you can use git show followed by the show value or the hash value that we have. And again, you don't have to type in all the numbers. Basically, the first 5 or 6 should be enough. So if I do 67078 EF, it should be able to identify it. There you go. So here, if you remember, this was our first commit, and you see it has got my initial commit, and it was all we did was we added hello world. So let's see if I want to go and see my what I saved in my second commit. I can just go there and I can select the hash value of second, that's B1AB, B1AB9, and I think it should be able to recognize. And you see, so here it shows me that this is my second line. So this is how you can use the hash values to go back and check your changes that you did as a part of your that commit. The other thing I wanted to show quickly since is git diff. So in case if you want, I don't think it will work now since everything is committed, or maybe it might. If I do git diff, okay, so nothing is coming since everything is committed. Basically, now let's go and make a change. Let's say we have got the second file, and let me change. This is my second file. You change this, and now you come back here, and then all of a sudden you cannot find out what you have changed because the text is so similar, or if the change is so small, it's really hard for you to know what you changed. So in that case, you can use diff, diff, and this should tell you okay, the reason for this not working is we haven't added the second file to our tracking, so sorry about that. Let me change our first file because okay, let's say instead of changing here, let me add one more exclamation right now. Let's see, I made this change, I come back next day and I'm just trying to figure out, oh, what did I change yesterday, how do I find out? So the easier way is, again, if you do a git status, it will identify that your file 1 has changed. You can see hello world has changed. Now if I do git def, so this will tell me what I have changed. So if I look here, you see here, so basically it compares to my working directory, and if I just look at the 2 lines, it tells me, so I had two exclamations earlier and now I have got 3. So in case you have to find out the difference between your working directory and your staging, you can just do this and it will show you. Now, but this remember, this diff works compares your code or changes from your working directory to the staging. Now let's say if I have to, let me stage this file, let me add this git add hello. Now okay, now if I have to, since I've added, now if I have to check here what changes I have made, let me do git status real quick. So it does identify that git has the file has changed. Here also I can use the same thing. I can do git def. The only thing I have to add is due to 2 dashes followed by staged, and this will tell me, this will compare my file with my repository. So basically you see here, this file that we staged, and this file is what we have in our repository. So basically this way you can go and compare it from your staging directory. And one more note, this staged was also called as cache, so you can also kind of use cache, but staged was added in the latest version and is much more meaningful. And the last command that I wanted to show before we wrap up today is the remove. So you can either go and delete the file from here. Let me commit before I do that. Git commit -m, say final commit. Okay, sorry. You see, git commit -m final, and there you go. So this has changed. Now let's say I go and delete this file. So this is one way of doing it. I can delete it from here and Git will identify, or I can just go and rename it. Let's say make it hello world 1. Now okay, so now for Git this is a change, because the file that we had is no longer there. So if I do Git status, so you see it says that untracked file get help, because even though we have renamed, forget it's a new name, or it's kind of a new file. So let's do this. Let's go ahead and add both the file to our staging area. Alright, now if I do Git status, you see it has find both the files now. And here if you see, now it identifies that file has been renamed. So you see, since we just did the rename, basically Git is smart enough to know that the file has been renamed. Now let's do Git commit -a. Since I have farm to kind of want to commit everything, I can have -a, and then I can also have m for message commit everything. Alright, now this one will go, and you can see it has added 2 files, and if I go and look for the status again, it will have nothing. So the reason why I did this, because I wanted to show you a shortcut how you can do this. So let's say if you want to delete a file, let's see, it's here, right? So I can do git rm. Let's say I'm doing hello world.txt. Now you see it has deleted the file, and if I do git status, so Git does identify that it has you have deleted the file. So basically now if I do git commit -n, so here also it identifies that one file changed 3 deletions, delete more for all. So basically now if I do git status again, probably there's nothing more to change, and if I go back to my editor or the project folder, you see my first file is gone. So this is another way of deleting the file. So alright guys, so this is all I wanted to show. Basically I think this is all that you will ever use with Git. So in case if you have any questions or any comments, do leave me a comment in comment section, and I'll try to get back to you. And in case if you like this video, please like this and subscribe to my channel. So thank you for watching. Thank you, and good luck with learning Git.